Alright. Hello, Jasenia Butello. This is Mr. Wall, or actually, I'm not no longer a teacher anymore, so you can just call me Nick Wall. I was Nate Golden's roommate last year, and I taught in CMS as a pre-calculus teacher at Olympic High School, and I'm making this video for you just to help you out at Mr. Golden's request, because we're all a team here. So, now we're looking at sequences, and sequences are a pattern of numbers. So let's just get some basic terminology. So a sequence is a pattern of numbers. So it's we can even say it's a list of numbers that follow a pattern. So a pattern. I'll even, there's multiple definitions, but I'm just gonna say it's a list of numbers. And usually these numbers usually they follow a pattern. They follow some pattern, okay? And we have types of sequences: arithmetic, geometric, or neither. And so we can have multiple types. With an arithmetic sequence, the trick here is that you are always adding. So each additional term. So with an arithmetic sequence, the whole idea is that for each new term, you add a value. So you add to find the next term. So you add to find the next term. So an example of this could be, let's say we have our term number and our term value. So our term number could be, if we have the first term, the second term, the third term, and we could have 4 plus 3 is 7. Sorry, it takes a while to load. And this is an example of an arithmetic sequence because you just add by 3 each time. So plus 3 plus 3. And so we have 3 right here, which the value that you add, this is called 3. That is called the common difference. That's the value that you add each time. And you just do it by taking a term number and subtracting it from the previous term. So the common difference, we find that we use the terminology an minus 1. And what this is saying is, let's do the example with this specific instance. We can do a3 an minus 1, that's just the previous term from an. So a3 minus a2, that's a3 is 10. That's saying the third term minus the second term is 3. That's the common difference. Or you could do the second term minus the first term, each term minus the previous term. That's 7 minus 4 is 3. So that's how you find the common difference. And if you could look at this pattern, you could say, what's the fourth term? Think about it. Just add 3, that would be 13. So the fourth term would be 13. The next is a geometric sequence, and you have a common difference. So a geometric sequence, you have a common difference, and that this just means that so it's a common ratio, and so you have to multiply to find the next term. So the sequence, but you have to use multiply to find the next term. Multiply to find the next term. Now, the same thing. Let's just do a term number and a term value. 1, 2, 3. Let's do 2, 4, 8. Each term is the previous term times 2. And so this is called the common ratio, R. And the term for common difference, that's D. R is the common ratio. And just find the common ratio by dividing each term by the previous term. So the common ratio here is just AN divided by AN minus 1. So the example, A2 divided by A1, that's 2, that's 4 divided by 2. 4 divided by 2, that's 2. And you do multiply by 2. Or you could do A3 divided by A2, that's another term divided by the previous term. That's going to be 8 divided by 4, that's 2. And so that's how you find the common ratio. So that's getting all the basics out. I wanted to get that terminology out. So I know it's been going a little bit slower than you would like, but if I wanted to be thorough in the explanation, if I'm being too thorough or going too slow for you, I can try to be, you can always skip ahead. So let's actually go to this worksheet. So here we have to do 6 plus what is 11? Well, 6 plus 5 is 11, and 11 plus 6 is 17. And here we see we're not adding a consistent number, and we're not multiplying by 6 consistent number, because 6 plus 5 is 11, 11 plus 6 is 17, so we're not adding by a consistent amount. And because of that, it's neither. We don't have a recursive formula. We don't have an explicit formula. But we know that we're adding by 1 more each time. So we do 6 plus 5 is 11. 11 plus 6 is 17. That's the third term. The fourth term is 17 plus 7. That's 23. So let's write this out. We have 6 plus 5 is 11, plus 6 is 17, plus 7 is 24, plus 8 is 32, plus 9 is 41, 1, 2, 3, 4, 5, 6, plus 10 is 51. So this is the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, the seventh term, plus 5, plus 6, plus 7, plus 8, plus 9, plus 10, plus 11. The eighth term, 51, 61, 62. The ninth term, 62, plus 12 is 70. So 51 plus 11 is 62. 62 plus 12 is 74. And then the 10th term is going to be plus 13, so it's going to be 87. So from that, we can find that the 10th term is 87, and we use the terminology. The 10th term, we just say A10. That's equal to 87. Now, let's look at the next term. We have negative 3, 9, negative 27, and 81. So now we look at what do we multiply, and you are correct. We multiply by negative 3 because our common difference is negative 3, and we can do that. Let me just erase some of this right here. We prove that just by testing that you can just divide each term the previous term and get the same value. 9 divided by negative 3 is negative 3. Negative 27 divided by 9 is also negative 3. So we know that's our common ratio. So r is equal to negative 3. So that's geometric. So, but now we need a recursive formula, an explicit formula. And this is the part where you need to know what those terms are. And so for geometric, you can have an explicit formula and a recursive formula. So hopefully you have all this down. I'm going to clear annotations. Allow me, come on, clear annotations. I think it's taken a while, but I'm going to list out just formulas for arithmetic, geometric, recursive, and explicit. Okay, so we have arithmetic, and with the arithmetic we know that we have an arithmetic series. The recursive formula for an arithmetic is going to be, and think about it, this should make sense, A1 or AN, which means any term in a recursive in a sequence that is arithmetic is equal to A1 AN minus 1 plus D. And what that is saying is that each term is equal to the previous term plus the common difference. And the common difference here for the arithmetic series is that D is equal to AN minus 1, or the common difference of an arithmetic sequence is always each term minus the previous term. Now you have a geometric sequence. The common ratio for a geometric sequence is R is equal to AN divided by n minus 1. Each term divided by the previous term. And so the recursive form of a geometric sequence is going to be an is equal to an minus 1 times r. Each term is equal to the previous term times the common ratio. Now we have the explicit form. And the explicit form gives you a function where the input is the term number and the output is the sequence value. So for an arithmetic sequence, you're going to have an, and this is just the formula. If your other teacher wants to determine how this is derived, that's for another day. The form is going to be an is equal to a1 plus d times n minus 1. And for geometric, it's going to be an is going to be, and let's be absolutely certain. Arithmetic and geometric explicit formulas. Alright, and let's search. Okay, yes. An is okay. Yep. An is equal to a1 times r to the n minus 1 power. So this is saying each term is equal to the first term times the common ratio raised to 1 less than that term number power. So let's actually go back to your worksheet. How are we on time here? It's going to be a 30-minute video. Geez, sorry. But it'll walk you through it. So once again, this is neither. And the term number here is going to be, what is that? I have to do that all over again. So you have 6 plus 5 is 11, plus 6 is 17, plus 7 is 24, plus 8 is 32. Well, yeah, plus 8 is 32, plus 9 is 41, plus 10 is 51, plus 11 is 62, plus 12 is 74, plus 13 is 87. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the 10th term is 87. Let me also say that that's 87. Okay. Now here, this is a geometric sequence, and we need to find a recursive formula and explicit formula. So let's go back to this original page. Geometric, each term is the previous term times r, that's recursive. Explicit, each term is the first term times a common ratio raised to the n minus 1 power. So, recursive formula. Each term, an, is the previous term times our common ratio. So an is equal to an minus 1 times r, the common ratio, and here our common ratio is -3. And the explicit formula is an is equal to a1 times r to the n minus 1. So here a1 is -3 times r, which is -3, raised to the n minus 1 power. Now we need to find a5. And so a5 would be, we plug in 5 into this explicit formula, and we would say a5 is equal to -3 times -3 to the n minus 1 power. That's 5 is n, because a5 matches up with an. So 5 minus 1 is 4, -3 to the 4th power. So we say -3 to the 4th power, -3 times -3 is +9, times -3 is -27, times -3 is +81, and 81 times -3, let's see, 8 times 3 is 24, so 80 times -3 is -240, and then 1 times 3 is 3, so it'd be -243. So a5 would be -2, let me go back here, that would be -243, and that's what I'm plugging in, -3 a1 times -3 r raised to the 5 minus 1 power. So I'm just plugging in these formulas. Here we add 2, then we add 3, then we add 4, then we add 5. So this is neither, and because this is neither, we don't have to worry about writing a recursive formula or an explicit formula. Let me go back here. All right, and we need to find the 9th term. So the first term is 1, plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15. So the next term is plus 6. So that's 1, 2, 3, 4, 5. It's a 5th term, 15 plus 6. So the 6th term is 15 plus 6. That's 21. The 7th term is 21 plus 7. That's 28. The 8th term is 28 plus 8, that's 36. And the ninth term is going to be 36 plus 9, and that's 45. So A9 is 45. This term is geometric because we are multiplying by 1/3, and you've correctly diagnosed that. So the recursive formula, AN, is equal to each term is equal to the previous term, AN minus 1 times 1/3. So each term is equal to the previous term times 1/3. And then we have the explicit notation, which is going to be AN is equal to A1, and A1 is equal to 1/2 times R, and here R is 1/3, so 1/2 times 1/3 to the n minus 1 power. And so A6, and let me use this opportunity to clear annotations. Okay. A6 would mean A6 is equal to A1 times R to the n minus 1 power. So here, that would mean A1 is 1/2, R is 1/3, and to the 6 minus 1 power, that's to the 5th power. So 1/3 to the 5th power, here's how we would go about that. We'd essentially just do 3 to the 5th, right? So that's 1 times 1 times 1 times 1. So that's 3 to the 5th. That's 3 times 3 is 9, times 3 is 27, times 3 is 81. Times 3, 81. Yeah, 81 times 3, we just said that is 243. Then 243 times 2 is going to be, so that's 2. So that's 3 to the 5th. So that's 1/2 times 1/3 to the 5th power. That's 1/2 times 1 over 243. And then 243 times 2 is going to be 446. No, sorry, 486. Everybody makes mistakes. Nobody's perfect. I gotta work it. Hannah Montana, Hannah Montana. 486. Let me switch back to this. 486. Once again, just using those formulas. Okay. Arithmetic. You subtract by 4 each time. So this is our first arithmetic example. All we're saying is that each term is equal to the previous term. And what's a common difference? Minus 4. Good. So each term is equal to the previous term minus 4. And then our explicit formula is just going to be an is equal to a1, and here a1 is 17 plus d times n minus 1. So here d is -4 plus our d is -4, but we multiply that by n minus 1. Sorry, it's a little bit cramped, but hopefully you can hear me narrating. So then we need to find a20, and to find a20, we would do the math that we just plug in 20. So the a20 would be a1 17 plus d, and here d is -4 times n minus 1. So 20 minus 1 is 19. -4 times 19 is, that's going to be -4 times 10 is -40. -4 times 9 is -36. -40 plus -36, it's -76. That's 17 plus -76. That would be -66, -60, -59. So this answer right here would be -59. -59. Clear annotations already. It's gonna be a long video. -17 minus 6, 11 minus 6, 5 minus 6, -1. So here, an is equal to, and you were right, minus 6. So an minus 1. Each term is equal to the previous term, minus 6. Each term is equal to the first term plus the common difference, which is -6, times the term number minus 1. So the 18th term would be a18 is equal to 17 plus -6 times 1 less than 18 is 17. So that's -60. 7 6 is 42. -42. So -102. 17 minus 102. So that's -92. -90 plus 5. That's going to be -85. So -85 here. That's our value, -85. And once again, please clear annotations. Please clear. Okay, next one is geometric. You multiply by 1/2 each time. That is correct. So
each term is equal to the previous term, a n minus 1 times 1/2. And then the explicit formula, each term is equal to the initial term, which is going to be negative 20, times our common ratio, which is 1/2 raised to the n minus 1 power. So the seventh term would be negative 20 times a1, which is, times r, and r here is 1/2 raised to the n minus 1 power, which means that's raised to the 6th power. So that's going to be 1/2 to the 6. So since we just need to find 2 to the 6, so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. 2, 4, 2, 4, 6, 8, 16, 30, 2 to the first, 4, 2, 4, 8, 16, 32, 64. Okay, so that's negative 20 times 1/64. So that would be negative 20 times 1/64. That would just be negative 20/64. And negative 20/64, we'll keep that in the unsimplified version. So we do negative 20 over 64, but I would also write here, in simplified, you could do negative 10 over 32, negative 5/16, and then I don't think you can simplify that further. So the most simplified version that they might want is negative 5 divided by 16. Okay. All right. Here, 1/5, 23, 40. So here, this is definitely, this one is hard to determine. So no shame in struggling with this one. We got to find, are you adding a certain value? It's hard to say. So we have essentially 3/15, because 1/5 is, so we have 3/15, then 23/15, then 43/15, then 63/15. So let's put it this way. 1/5, in terms of 15ths, hopefully you just do the conversion in your head. 1/5 is 3/15. So you have 3/15 for the first term, then 23/15 for the second term, then 43/15 for the third term, and then this says 21/5. Well, 21 times 3 is 63. So then you have 63/15 for the fourth term. So actually, if you see something, you're adding 20/15 each time. So each term you add, so common difference is equal to 20/15. You actually just kind of have to see that. Rigorously, you could just find one term, subtract by their terms. You do 23/15 minus 3/15. You have to convert it, but that would become 20/15. And you could do that for any term in the sequence. So this term is arithmetic. Each term is equal to the previous term, an minus 1 plus 20/15. Sorry, that's 20/15. And then for explicit form, we say an is equal to a1, which is let's keep this in the standard common denominator. A1 is 3/15 plus D, which is 20/15 times n minus 1. We need to find the fifth term. And so if 63/15 is the fourth term, just add 20/15. So it'd be 83/15. So A5 is 83/15. So just added 20/15 from the fourth term to get to the fifth term. Here we add 3, we add 5, you totally get this. So that is neither. That means we don't write recursive or explicit. To find the ninth term, well, let's see. Let me do some erasing here. First term is 1, 4, 9. So you're adding by 2 each time instead of 3. So 9 plus 7 is 16. Good. 25. This is the first, the second, the third, the fourth, the fifth term. We're looking for the ninth term. So, but 16 plus 9 is 25. So next time we're adding 11. So 25 plus 11 is going to be 36. That's adding 11. This time you're going to add 13. 36 plus 13 is 46. Or 36 plus 10 is 46. And then it becomes 49. Then we go to 15. 49. 59. 64. So 49 plus 10 is 59. 59 plus 5 is 64. That's term 7. Then it's term 8. We need to find term 9. And so then term 9 you would add 17. So 64 plus 10 is 74. And then 74 plus 6 is 80. But then add that last one, you have 81. So A9 is 81. And here's another pattern that I'd like you to see. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. So notice all these terms are perfect squares. I wanted to solve that out manually for you, but also if you can find that shortcut, notice that you could essentially say if you wanted to write, I know you don't have to write a recursive formula for this one, it doesn't ask you, but if you wanted to write a recursive formula for this one, you could say each term an is equal to So, for example, first term is 1 squared. The second term is 2 squared, right? So that would be an is equal to n squared, okay? All right, so battery's running low. Let me try to finish this up really quick. This is geometric. So yeah, you got the pattern right. Try the last 3 for these ones. Yeah. So these are geometric. You got the pattern right. Use the pattern here to help you out. And then this last one, you are adding 6. Remember, because it's negative numbers, you add 6. So this is arithmetic, and your common difference is equal to positive 6, not negative 6. So use the examples that I did, 1 through 9, to help you with 10, 11, 12. All right, text Mr. Golden for help.